I'd like to take the integral of 1 over the square root of 8 plus 2x minus x squared dx. To do this, I'm going to use trigonometric substitution, and that's going to require me to change my integrand into something that involves either a sum or a difference of squares. And so I'm going to write my 8. I'm going to factor out this negative so that it's an easier thing to work with. And then I'll have minus x squared minus 2x. I want to complete this square, and so I'm going to add 1 to this to make it a perfect square. That's inside a negative sign, and so I need to add 1 to balance it out. And so combining my constants and changing this into a perfect square, I have the integral of dx divided by the square root of 9 minus the quantity x minus 1 all squared. And so now I have this difference of squares inside the radical, and this is perfectly set up for trig substitution. So I'm going to change my square into a single variable so it's a little bit easier to work with. So if u is x minus 1, du is dx, and I end up with the integral of dx, or du, divided by the square root of 9 minus u squared. To put it in the right form for a trig substitution, I'm going to take the 9 and factor it out of the radical. And so I end up with the integral of du over 3 times the square root of 1, perfect, minus u over 3 all squared. Or if you prefer, u squared divided by 9. Generally, when we're looking at a difference of squares in this form, we're going to use the identity the cosine squared of the angle is 1 minus the sine squared of the angle. So cosine squared of theta is 1 minus sine squared of theta, which means we want to take our argument, the u over 3, and replace it with the sine. So in other words, I want u over 3 all squared to equal sine squared of theta, which means I want u to be 3 times the sine of theta. In this case, du is going to be 3 times the cosine, d theta, and so I can take these and substitute them in and end up with something I can take the square root of. I get this is equal to the integral of 1/3. Du gets replaced by 3 cosine of theta d theta. And in my denominator, I have the square root of 1 minus sine squared. And so the 3's cancel very nicely, and I'm just left with the integral of the cosine of theta divided by the square root of cosine squared. So cosine theta again. So I have the integral of 1 d theta, which means my integral is going to be just theta plus the constant c. Now I can use my substitution here to solve for theta. And so if u is 3 sine theta, then u over 3 is sine theta. So theta is sine inverse of u over 3, which means this is going to be the inverse sine of u over 3 plus c. From earlier, u was equal to x minus 1. And so to write this in terms of x, I just have to replace the u by the x. This will be sine inverse of x minus 1 divided by 3 plus my constant c.